Hi everyone. We will see unit number 12, time series analysis. Just we will share that we are going to see. So in this one, we are going to study what is that study of our objective, and the introduction of the time series, definition and utility of time series analysis. What are the components of time series and how we are going to decompose the time series? So and then adjustments, preliminary adjustments, and sum up and keywords and terminal questions we are going to see. So let us see what is our objective for our studies in this time series. So the first one, we will define the concept of the time series analysis, and appropriate role of time series is in short term forecasting. And these are our objectives. Now we will move on to the introduction. So here we will see what they mean by time series and how where we are using these and all. So in this previous units, we have learnt about that usually statistical data we are collecting, that collection of data only we are considering here. So the nature of data is varying from case to case. This and all we are aware of that one. So here we have come across the quantitative data for a group of respondents collected with a view to understanding more than one parameter, such as investment, profit, consumption, weight, etc. So when a nation or state or institution or a bus, likewise, if you take anything, so our intent to study the behavior of some elements, just price of a commodity or exports of some commodity or a product or investment or sale of any commodity or profit of anything we can have. So behavior, it differs from a period of time. Behaved over the period of time, it may vary. So the information shall be collected for a fairly long period of time. It may be of long period means we can have for more than 10 years, more than 20 years we can. So for a long period of time, we are collecting. So usually at equal intervals. So time of interval means the five. That is the 5 years once we can have this. So likewise, we are collecting the data. So thus a set of quantitative data collected and arranged on the basis of time. On the basis of time, we are. So this is called as time series. So depending upon our research objective, the unit of time may be a decade or a month or a year or a week, etc. It may differ. So the typical time series or the sales of a firm in such successive years, monthly production figures of a cement mill, daily closing price or shares of Bombay stock market, hourly temperature of a patient. So it may have. So these are the some typical time series of the we are having under that some successive years we have. Okay. So now the quantitative, we are talking now, we will talk about that quantitative data. Quantitative data of a variable under the study are denoted by. So here the notations we are generally we are using as y1, y2, etc., yn, and the corresponding time units we are considering as t1, t2, etc., tn. So the variable y shall have variations, and as you will see up downs in the values. So according to the time, it may vary. So according to the time limit. So instantly we are it is coming into our mind that the time is responsible for all these changes. Okay, but it is not true, because the time is not cause. The change of variable doesn't affect or not affecting this one. So the only fact that there are, which we must understand, is that there are a number of causes which affect the variable, and we have operated on it during a given time period. So hence the time becomes only a basis for time analysis. So however, that is hence we can say that In analysis related to so hence we can say that in the analysis of time series, the time is most important factor because the variable is related to time, which may be either or year or month or year or hour or even minutes or second also we can have. So here we may many authors have defined the time series in many ways. So we can have some of the definitions of the time series here. So a time series is a set of all statistical observations arranged in chronological order. So this is stated by the author Maurice Hamburg. So he gave the definition of time series in this manner. And one more person, Wissel and Vellet. So many people have given. So Wissel and Vellet. He gave the definition as when quantitative data are arranged in the order of their occurrence, the resulting statistical series is called time series. And the Spiegel, he delivered the time series as a time series is a set of observations taken at a specified time, usually at equal intervals. So just now we have stated that one. So mathematically, a time series is defined by the values y1, y2, etc., yn, and with the temperature closing the period, etc. So time t1, t2, etc., tn. So generally, the y is a function of t. So y is equal to f of t we can have. So that's that some definitions we may have under the time series. So it is clear from the above definitions that the time series consists of data arranged in chronological order. Thus, if we record the data relating to the populations per capita income, prices, production, etc., for the last 5, 10, or 15 or 20 years, or some other time period the series is so emerging would be called the time series. So here this is the basic definitions we have. Okay. So now we will move on to that our definition and utility of the time series analysis. So based on the previous discussions, we can understand the definition of few statisticians how we are. Okay. So now for the following reasons, we may have this. So where we are having the utility of the time series analysis. So utility is not only for that academicians or economics or businessmen or scientists. For all them, it is very very useful. So for the following reasons, it is very useful. So the first point is it helps in understanding the past behavior of the variable under the study. So uh, it facilitates in forecasting the future behavior with the help of the changes that have been taken place in the past. And the third one is it helps in planning future course of action. And the next point we may have is it helps in knowing the current accomplishment. Also, it helpful to make comparison between the different time series and significant conclusion can be drawn from there. This we can say that the need for the time series analysis arises in research because so these are the valuable points we are having. So for what reasons we are so when we are talking about the utility of that time series, so why and for the following reasons researchers need time series. So here we want to understand the behavior of the variables under the study. So we are collecting the data and we want to study the behavior of data of that collection means time series is very useful. And similarly, the expected quantitative changes in the variable also under study. And similarly, we want to estimate the effect of various causes in quantitative terms. In nutshell, that the time series analysis is not only useful for researchers but also in all the field already we stated. So for in governments for devising appropriate future growth strategies. So this is very important for the growth of future strategies. This time series plays a vital role. We are having the components of time series. The time series, if you have informed that the prices of 1 kilogram sunflower oil was in 1940, very long ago. So it is rupees 0.50, that's 50 paise we have. But in 1980, it was rupees 30, but it is 2004, it is rupees 70. So if you are asking if we can ask that question: shall sunflower oil be sold again in the future? For this about prices, that is 50 paise or 30 rupees per kg. But we can say that it's quite impossible to this price in the right now. So likewise, so according to the past, we are going to predict the future by making use of this one. So what can be the answer for this one? So sunflower oil can sold again in future for rupees 60 per kg, not out. So we can say that. So per kg, if it is 60 means we can say that it is yes. Okay. So however, the thought about how you answered the above two questions have. So probability the first two questions we might have that answer as no. Okay. And the analysis of these answers shall lead us to arrive at the following observations. So, what are the observations we have? So, see this one, there are several causes which affect the variable gradually permanently. Therefore, we prompted to answer no for the first questions. So, similarly, for the second question, there is for the reason prompted to for the second question, we are saying that it is yes. Okay. But the causes which affect the variable gradually and permanently are termed as long-term causes. The examples for such causes are increase in the rate of capital formation, technological innovations, the introduction of automation, changes in productivity, improved marketing, etc. The effect of long-term causes is reflected in tendency of a behavior to move in upward and downward direction, termed as trend or secular trend. So how we are introducing this technical term we are having trend and secular trend. It reveals as to how the time series have behaved over the period under the study. The causes which affect the variable for the time being only are labeled as short-term causes. The short-term causes are further divided into two parts. One is regular and another one is irregular. The regular causes are further divided into two parts. One is cyclical cause and another one is seasonal causes. So the cyclical variation. So here we are coming main entering into the components of time series we have. Okay. So the first one we have is like first one we are having that is a secular trend, cyclical variation, seasonal variation, and irregular variation. So here we will see that cyclical variations. So in the cyclical variations are termed as business cycle fluctuations as they influence the variable. So the business cycle is composed of prosperity, recession, depression, and recovery. The periodic movements from prosperity to recovery and back again to prosperity vary both in time and intensity. The seasonal causes like weather conditions, business climate, and even local customs or ceremonies together play an important role in giving rise to seasonal movements to almost all the business activities. For instance, the yearly weather conditions directly affect the agricultural production and marketing. So this has been known fact to us. So, so seasonal variation analysis will be possible only if the season-wise data are available. So it's quite true. So in fact, this must be checked first that whether for analyzing the seasonal effects, various methods are available. So among the seasonal index by ratio moving average, so these are the following methods we are having under the seasonal index. So the first one is ratio to moving average method. So this is most widely used method we have. However, if the data collected data provides only yearly values, there is no possibility of obtaining seasonal variations. So therefore, the residual amount of after eliminating the trend will be effect of irregular random causes. Irregular causes are also termed as erratic and random causes. The random variations are caused by infrequent occurrences such as wars, strikes, earthquake, floods, etc. So, due to these reasons, either go very deep towards or very high upwards because of this. So, for the foregoing paragraphs, um, we have seen that the types of time series components we have said. So we are listing at the long-term causes. We are seeing that it is a secular trend or trend. Just we will recall that one what we have seen. So long-term causes we have as a secular trend or trend, and short-term causes or we are having as cyclical, and then we have seasonal indices. There is seasonal, irregular, erratic, seasonal, cyclic variations, and then secular trend, seasonal variations, cyclical variations, and irregular variations we have. So these are the we are having. So secular trend we have, cyclical variations, and irregular variations. Now we will see the decomposition of time series. So in this decomposition of time series, the decomposition and analysis of time series are one and the same thing. The original data or observed data is the result of the effects generated by a long term and short term, namely the trend T we are using. So already we have listed the components of time series. So here we are using the notations we are having. So trend T used by the letter T, variable T, and cyclical C we are using, seasonal S we are using, and irregular I we are using. So find out the values for each component is called the decomposition of time series. So here how we are going to do the decomposition. So this decomposition is done either by the additive model or the multiplicative model of the analysis. Which of these two models is to be used in analysis of time series depends upon the assumption that we might make about the nature and relationship among the four components. So this is the first one. That is either by, we have said one is additive model and another one is multiplicative model of analysis. The first model we will see additive model. So what is this model? So it is based on the assumption that the four components are independent of one another. Under this assumption only we are proceeding. So the pattern of occurrence or magnitude of movements in any other particular component are not affected by other components. So in this model, the four components are expressed in the original units of measurements. Thus, the original data or observed data y is the total of four component values is that is y is equal to t plus s plus c plus I, where t, s, c, I represent the trend values. The seasonal variations, the cyclical variations, erratic variations respectively. So already we have seen. So y is equal to the total of the four components values. So y is equal to this is additive model we have. Y is equal to t plus s plus c plus I. Now we will move on to the next one, multiplicative model. So in this model, under which assumption we are going proceeding here is the causes giving rise to four components are independent. Okay, independent we are assuming. So that the original data or observed data y is the product of four component values. That is y is equal to t into s into c into I. So in this research, normally the multiplicative model is more suited for more frequently for the purpose of analysis of time series, because the data related to business and economic time series is the result of interaction of a number of factors which individually cannot held responsible for generating any specific type of variations. Let us consider the example. For construction of time series according to the multiplicative model, we'll see the table which represents the components of a hypothetical series. So this is the table we have. See this table. We have year wise we have as quarter. That is, we are dividing that into quarters. So 1, 2, 3, 4 we have the series. O observed one, that is a T, and seasonal S, and then cyclical C. So that we have in the seasonal components we have. So we can list this in this manner. So it is decomposed of time series. So hypothetical time series and its components we are decomposed into quarterly. So according to multiplicative model, y is equal to t into s into c into I. This we have 79, or we can have as 1 year and 1 quarter. See this one. 79, the very first one we have 1 year. It is coming on the first year, first quarter. So that we have, that's why. So that is equal to 80 into 120 by 100 into 82 by C. That is T into S into C into I. That we are considering. So 80, the corresponding T is 80. Corresponding seasonal S is 120, and C cyclical erratic is 82. So we have considered, I'm coming back to that, so 80. So 120 divided by 100 into 80 divided by 100. So this is the first thing. And similarly 130. 130 is 2 year and 2 year and 1 quarter. So this is 100. 100 is nothing. We have 130. See, let us check. 130. So corresponding value we have as 100. See this one, 100, 120 and 108. So we have 100 into 120 by 100 into 108 by 100. So likewise, we can have for each figure. So this each quarterly figure Y is the product of T, S and Ci. So such a synthetic composition looks like an actual time series and has encouraged the use of model as a basis for analysis of time series data. Now we can have this as 12.5 preliminary adjustments. So here we are proceeding how we are doing the adjustment in the raw data. So first one, calendar variations. So as we are aware that all the calendar months we do not have the same number of days as we know. Okay. So for instance, the production of month of February may be less than the other month because the fewer days or if we take the holidays into the account of variation is greater. Therefore, the adjustments for calendar variations have to be made. So the next one is price changes. Next one is price changes. The price level changes depending on the period of time. It is necessary to convert the monetary values into real values after taking into the consideration the price indices. The next one is population changes. The population grows constantly. This allow also calls for adjustment in the data for population changes. In such cases, if necessary, the values can be computed. Okay. So the next one is a multiplicative model as we saw. So it is based on the assumption that already we have seen, assumption that the four components are independent, interdependent. So now we are sum up that what we have seen. Now this unit has introduced you to the concept of time series analysis. So we have seen what do you mean by time series, where we are using, how we are analyzing the time series, and what do you mean by what is the long term and short term goals we have the institution we have of institution, and what are the techniques we are using here the time series, and the quantitative values of the variable under the study are denoted by already we have seen y1, y2, y3, and corresponding time series we are having as t1, t2, etc., t3, and the time becomes the basis of this analysis. So time is not the cause, but changes in the values of the variable are not the effect. So these are the sum up we are having. The keywords we are using in this units are time series and the secular trend we have. So time series already we know it is a data or any on any variable accumulated at regular time interval. So this is the word we have time series, and then secular trend. Secular trend means a type of variation in time series, a long term, the long term tendency of a time series to grow or decline over the period of time. Okay, so for a long period of time it is growing. So what about the tendency of the time series, whether it is going to decline or it is going to grow? So according to the analysis data what we have, we are analyzing in this manner. So what is the tendency of the time series, whether it is going to decline or it is going to grow in a certain period of time. So that a type of variation that is called as secular trend. And the next one is price changes. So as price level changes are inevitable. So these are the sum up that we have. And the terminal questions we have is um, we can practice this question. How far you have understood this unit? So state whether that the following statements are true or false. The time first, this is A to F we have. That is first A we have as time is the cause for the ups and downs in the values of the variable under study. Okay, so the next one is the variable under the study in time series is denoted by Y. Time series is denoted by, is it Y or T? You have to decide. Okay, so the next one is the trend values are a major components of time series. Okay, if it is so means yes, or if it is no means what? No, N, false. So